Here we need to check that two functions sine of x and cosine of x are linear independent or not. So we will always start by say a of sine a times sine of x, b times cosine of x equal to 0, right? Function 0. So function 0 means that anything, the function 0 map, say on the value of x to O of x equal to 0. So when I can write O of x, where a and b are real number. So what do we have now? We can just check or put the value of x, because the two functions are equal for all x in the domain, right? This is all x in R. So the function go from R to R. For example, 0 function go from R to R like this. So this is true. Two functions are equal if they are equal for all the value of x on the domain. So now, in particular, say let me call it star. Notice that star is true for all x in R. So in particular, it must be true for some particular x, right? For x equal to 0, say. So sine of 0 equal to 0. You draw the unit circle, so you have sine of 0 equal to 0. Cosine of 0 equal to 1, right? Cosine of 0 equal to 1. Sine of 0 equal to 0. So we have a sine b equal, because this is true O of 0, so this is 0. This is the same as b, because a times 0 already. B times 1, 0. This is our first equation. Let's put it on. The second one is also must be true. Star is true for all x. So star is true in particular for x equal to pi over 2. Pi over 2, so a sine pi over 2, b cosine pi over 2 over pi over 2, which is 0, because this function, so map everything to 0, so 0. This is the same as sine of pi over 2, so it's 1. A times 1 plus b times cosine of pi over 2, so it's 0. Maybe we should compute it. Just write one more line. B equal to 0. And I write one more lines. A equal to 0. So we have A equal to 0 and B equal to 0. Both equal to 0. Therefore, this equation give us A equal to B equal to 0, right? A trivial solution. hence sine of x and cosine of x is linearly independent.